about the notion of symmetry. So go ahead and highlight your title for me, please. And then highlight, first question, what is symmetry? Okay. You all have used the word symmetry and seen the word symmetry before, mainly when you're talking about something being symmetrical. When two things are being symmetrical, we're talking about two halves of my picture that are completely identical. So symmetry is when an object is cut in half. The two halves are identical. Okay? We have three different types of symmetry we can talk about. We have line of symmetry, rotational symmetry, and point of symmetry. The most famous that you all are aware of is line of symmetry. What line makes my picture symmetrical? Okay. Rotational symmetry is when I rotate my picture, is it ever going to make the exact same picture shown when I spin it around its center? Okay? And the last one is point of symmetry. Okay? Point of symmetry and rotational symmetry are a little bit similar. The big thing about point of symmetry is it can only happen at 180 degrees. Rotational symmetry can happen anywhere between 0 and 180 degrees. And we'll get there in a minute. So let's first talk about line of symmetry. Okay? Line of symmetry is the line or lines that cuts an image to make symmetrical pieces. Okay. So, if we're looking at a shape, and I want to determine the number of lines of symmetry each shape holds, you have to look at it carefully. So let's take a look. If I first look at a rectangle, I can draw a line of symmetry right here, because if I fold this paper along this line, this picture is going to be the exact same on both sides. Okay? And that's the exact same if I do this line of symmetry. If I fold my rectangle along that line, I'm going to get the exact same shape on both sides. Okay? What about if I cut my rectangle like this? Does that produce a line of symmetry? No, because if I fold it along this line, it is not going to look the exact same on both sides. So that is not a line of symmetry. So in this problem, I have two lines of symmetry. Okay, let's look at the next one, trapezoid. If I cut it like this, vertically, yes, that's a line of symmetry, because if I fold it in half and if I had it drawn straight, you would have been able to see, yes, those are identical. What about if I do this? Is that going to work? No. So with a trapezoid, I have one line of symmetry. Okay. I now have an equilateral triangle. So if I have an equilateral triangle, let's figure out how many lines of symmetry there are. So if I fold my triangle along that line, that's a line of symmetry. Now what if I do it along this line? That's also a line of symmetry. And right there. So with a equilateral triangle, I have 3 lines of symmetry. And actually, with any regular polygon that you have, the number of sides is the number of lines of symmetry. That only works if your polygons are regular. Okay? So now let's check out the flags. American flag. Any lines of symmetry? If I cut it like that, nope, that doesn't look the same. Cut it like that, nope, that's not identical. I have no lines of symmetry. So go ahead and pause this video and let's see if you can figure out the other two flags on the screen. Okay? This flag right here has one line of symmetry. How about this flag over here? I have two lines of symmetry. So a line of symmetry is where my picture is sliced perfectly in half and they look identical on either side. Alright, perfect. So now pause this video and check out scalene triangles and isosceles triangles and see if you can figure out how many lines of symmetry are on those. Scalene triangle has no lines of symmetry. And an isosceles triangle has one line of symmetry. Okay. So flip this over. Let's look at some coordinate examples. Find the coordinates of 2 points that form a line of symmetry with the given picture. Alright, well first I want everybody to draw a line of symmetry on this triangle. Line of symmetry would be, draw straight, right there. I need 2 ordered pairs that are on this line. So I can say 5, 2, I can say 5, 4, I can say 5, 1. I can say a bunch of different values that are on that line of symmetry. So now pause this video and try the second example. Alright, this example, if I draw my line of symmetry, alright, it's at x equals -3. So 2 ordered pairs, -3, 2, -3, -1. Are these the only answers, ordered pairs that are on this line of symmetry? No, there's many more. Those are the 2 that I saw first. Okay. So now let's talk about rotational symmetry. Rotational symmetry is when you rotate an image and it produces the exact same image. Okay? When I rotate an equilateral triangle, when I rotate an image and I spin it around the center that's given right here, okay, I want to be able to create an exact same image. And you have to be able to rotate this from 0 to 180 degrees. Okay? So let's take a look at an example here. So notice I have this triangle, and I'm going to drag a triangle over here. Exact same triangle. I want to spin this so it makes the exact same image between 0 and 180 degrees. So 180 degrees would look like this. I had it, this was the original, and I spun it all the way so it's basically upside down. Okay? So between here and here, I want to be able to produce the exact same image. And notice, if I go back to the original position, okay, and I rotate it this much, notice it is the exact same image. My triangle is pointing up, my triangle is pointing up. So an equilateral triangle does have rotational symmetry. Okay? And how we would figure out what that degree is we look at the exterior angles. And we'll talk about how we would do that next class. So now, what if I gave you a hexagon? Okay? These aren't on your notes, but make sure you are following along. Okay? I want to be able to spin a hexagon from 0 to 180 degrees, anywhere between there, to determine if I'm going to be able to produce the exact same shape. So if I turn it this much, oh, it's the exact same shape. If I turn it this much, it's the exact same shape. And I keep going because I'm not at 180 degrees yet. Now I am. See how it's completely upside down from before, where I was able to produce the exact same shape. Okay? Let's look at one more. Let's do isosceles triangle. Okay. Can I rotate this anywhere from 0 to 180 degrees where it's going to look exactly like this figure over here? Let's try. Nope, that doesn't look like it. Now it's upside down, which means it's at 180 degrees. So no, an isosceles triangle does not have rotational symmetry. Okay? So an equilateral triangle has rotational symmetry. An isosceles triangle does not have rotational symmetry. Last class, a little bit before, we talked about how regular polygons have the number of lines of symmetry based on the number of sides. I mentioned that before. Okay? Regular polygons also have rotational symmetry, so it makes them so powerful. Okay? So let's now talk about what point of symmetry is. Point of symmetry is almost the same notion as rotational symmetry, except it must look the same at 180 degrees, which just means it looks the exact same when it's upside down. Okay. Remember on the equilateral triangle, I didn't have to spin it all the way upside down for it to look the same, because it wouldn't. I had to spin it just a little bit. I had to actually spin it 120 degrees in order to produce the same shape. Point of symmetry can only look the same upside down. Okay? So if I go back over here and I don't hit the wrong button, look at this guy. If I drag him over here and I spin him completely upside down, does this look the same as this? Yes, it does. So this shape has a point of symmetry. Okay? Notice also, because it is between 0 and 180 degrees, he also has rotational symmetry. So let's look at one more. Let's look at H. If I spin H completely upside down, does this picture look the same as this picture? Absolutely. So it has point of symmetry and line of symmetry. It has point of symmetry and rotational symmetry. So rotational symmetry, check. Point of symmetry, check. Line of symmetry. How many lines of symmetry does this figure have? I cut it here? No. I cut it here? No. If I cut it here? No. No lines of symmetry. So look at H. Line of symmetry, point of symmetry, rotational symmetry. Line of symmetry, there's one. Point of symmetry, yes. Rotational symmetry, yes. If you have point of symmetry, you also have rotational symmetry. If an image has a point of symmetry, it also has rotational symmetry. Okay. If I go back to that equilateral triangle, okay, we talked about how this shape has rotational symmetry. See if you can find the original. Here's the original. Okay, it has rotational symmetry if I spin it this much. But what if I spin it completely upside down? Nope, this does not look the same as this. My base is on the ground over here. My base is up in the air over here. So this would have rotational symmetry, but it doesn't have a point of symmetry. Okay. So pause this video and talk about the type of symmetry a square has. A square has has 4 lines of symmetry. It has yes to a point of symmetry. And it has yes to rotational symmetry. Okay. These are the main facts about symmetry you need to know. Next class we will talk about how we can determine the degree of rotational symmetry if it's not exactly at 180 degrees.